Hello and welcome to Walking Talking Mocks with Haven Science. We're going to look at word equations and balance equations. We'll look at the subject knowledge you need to answer this style of question, then you'll be given the opportunity to answer an exam question, followed by an answer from me. To answer the question, all you'll need is paper, pen and something to time yourself with. We are going to use this example question to help explain the subject knowledge. If you are asked to give a word equation, you must give the name of the substance and not shorten it to its symbol equation. Reactants are the substances on the left-hand side of the arrow, and the products are found on the right-hand side. In this case, you are being asked about a displacement reaction. In your syllabus, you will have covered displacement of halogens as well as displacement of metals. A displacement reaction of a metal is where a more reactive metal removes a less reactive metal from a solution of its salts. You are likely to have done displacement reactions of metals in class. You would add a more reactive metal as a solid to an aqueous solution, which is our salt solution. The more reactive metal would break down and become part of the solution, whereas the less reactive metal will form as a solid. This is why displacement can be used in metal extraction. It's important that you remember this series of events as you may be asked to add state symbols to an equation. Look at the diagram. This is a model to show displacement. Here, C is more reactive than A, so C takes A's place. So imagining C is calcium, a highly reactive metal, A is aluminium, a less reactive metal, and B is representing the aqueous solution. At the start, all we can see is the calcium metal and the solution of salts. As the reaction progresses, aluminium starts to form as a solid and the calcium is no longer seen as it's now part of the solution. Here is the equation with state symbols included. However, the example question is looking at displacement of halogens. These are group 7 non-metals. Displacement of a halogen is when a more reactive halogen removes a less reactive halogen from a solution of its salts. So to answer this example question, what you should know is the reactivity of the halogens. Hopefully you remember that the reactivity decreases as you go down a group. This is because it gets more difficult for the halogens to take on an electron. Because they're in group 7, what they're aiming to do is to each take on one additional electron. So due to the increased shielding from the extra electron shells and the increased distance from the nucleus, it gets harder to take on an electron as you get further down the group. So for our question, this means that chlorine displaces the bromide, forming bromine and potassium chloride. Note the change in the suffix of the halogen name. Bromide becomes bromine because it's an element again, and chlorine becomes chloride because it's part of the aqueous solution. Now to look at balancing equations. Chlorine and fluorine become chlorine tetrafluoride. We are going to use diagram form to make sense of the large and small numbers used in balanced equations. The first thing you need to do is look at how many atoms of each element you have on either side. On the reactant side, we can see that there are 2 atoms of chlorine and 2 atoms of fluorine made up of diatomic molecules. All halogen gases are formed this way and are covalently bonded. This means that we cannot change the small 2 as it's not possible for more than 2 of these atoms to be bonded together. On the product side, we have 2 molecules of chlorine tetrafluoride. Each molecule is formed of 1 chlorine and 3 fluorides. Again, we cannot change that composition, so to ensure there are equal chlorines on each side, we form 2 molecules instead of 1. When adding up the reactants and the products, I find it helpful to put the chlorines in line with one another and the fluorines in line with one another. This means it's really easy to see which ones are out of balance. Straight away, from looking at the reactants and the products, we can see that there are fewer fluorine atoms on the reactant side compared to the product side. The only way we can balance these is to say that we will have more full molecules of fluorine formed. The simplest way to correct this is to say that we will have 3 diatomic molecules of fluorine, making 6 on the reactant side and 6 on the product side. As you can see, this is now a balanced equation. You will now be given time to pause the video and answer this question. Complete the word equation. Write a balanced equation and balance the following equation. You must now pause the video for 5 minutes and an answer will follow from me. Here is the completed word equation. The bromine has been able to displace the iodine, leaving potassium bromide and iodine. Here is the balanced equation. Hopefully you remember that the halogens, when they're elements, need to be in diatomic form, so require a small 2 next to them. And finally, here is our balanced equation. I've done the model form and I've also shown the comparison of reactants and products so that if you made an error, hopefully you can see where you went wrong. If you're still struggling with this, please come and see your teacher or visit one of our revision sessions on a Wednesday afternoon.